AMC 10A 2019 problem 20. So we have 1 to 9 as numbers and we're placing them on a 3 by 3 grid only once, and we're trying to find the possibility that the possible outcome of each sum in each row and column is an odd number. So this question, we just need to play it out as a possibility. So when I do this, I want to find out the sum of the combination of odds and evens that can result in an odd number. Well, I know by quick thinking that even plus even is an even number. So to make this odd, we must add a odd number. That should come as pretty common sense. And now we must consider the case of odd numbers. The sum of two odd numbers will be even because it will be 2 times the odd number. And 2 times an odd number will have a factor of 2, so it'll be even. So to make this odd, we must add another odd quantity to make this multiple of 3 to make this an odd number. So this will result in an odd, and this will result in an odd as well. And this will be the only two possible combinations of even and odds that can result in such a format. So now that we have this, we must now consider how many even and odd numbers are there between 1 and 9. Well, from quick thinking, 1, 3, 5, 7, and 9 will be odd numbers, and 2, 4, 6, and 8 will be my even numbers. So now we have the basic foundation to do this question. Because now I can just arrange each number so that I can match each of the criteria. I have to use 4 evens, I have to use 5 odds. So because I need to pair my evens with odds as present right here, I want to make sure that the odds can be versatile, meaning that I can apply the odds to no matter where that I choose. So I'm going to choose it to be my second column. Now, if I have it on my second column, I have to pair 2 evens with 1 odd. So I can pair 2 evens with the first column O and the second column O. And that will force the remaining to be O, O, and O. And let's see if this checks out. Well, even plus odd, this matches this criteria. Odd plus odd matches the second criteria. And this matches the first criteria. This matches the second. This matches the first. And this matches the first. So this possibility checks out. So that means that I can use this as a possibility in to be in consideration for how I arrange this certain question. So since this is the solution that I'm looking for, I need to see that am I overcounting for my solutions, because my solution will be in the form of the total number of arrangements of each of the 9 numbers. And in the numerator, it will be the total outcomes of each placement of even and odd numbers, such as the sum of each column and row will be odd. And the arrangement of 9 numbers on the 9 grid, 9 by a 3 by 3 grid, using only each number once will be 9 factorial, because we can only occupy each number once in each of the 9 spaces, and then the second will only occupy 8, the third will only occupy 7 spaces, and so forth. So the basic counting principle tells us will be 9 factorial. Now we just need to find the numerator. Well, I see here that we have a total of the 9 possible arrangements. We're only looking for one of those arrangements, so we only have to put 1 9 here. And of this 9 arrangements, we have overcounted, because no matter if I put even as 2, 4, 6, or 8, as long as this is another even number, the sum of this row will be a odd number. So I don't really care what even number I'm summing with the other. As long as they're both even, I'm fine. So I have actually overcounted some scenarios. So I must multiply by the 4 factorial, because each even number can occupy the 4 spaces that it's occupying right now, because this grid is the solution to the question. It's just that we need to rearrange this in a manner that can satisfy all the possible conditions. So the 4 factorial will be eliminating the overcounted even numbers in each position. And then that's the likewise case for the odd numbers, because I don't really care which odd number gets summed with the 2 other even numbers. As long as the number is an odd number, I'm fine. So the total possible arrangements of each odd number within each of the 5 spaces that it occupies is 5 factorial. So that will be a redundant cause, so I need to eliminate that in my overcounting sequence. So now I should check, and that should be all of the possibilities. So now we can go on with this question. So we can eliminate 5 factorial from 9 factorial, becomes 9 times 4 factorial, or 9 times 8 times 7 times 6. And 9 can be eliminated with 9. 4 factorial is 4 times 3 times 2. So 4 times, or 3 times 2 will be 6. Eliminates with 6. 4 eliminates with 8 to be 2. So this becomes 1/14. And I look up, and yep, answer choice B will be our solution.